In this lesson, we are going to do just a real quick review of some different measures of center concepts. So, in this particular example, at Company A, each employee gets a $1,000 raise in a year, and at Company B, each employee gets a 3% raise. What will happen to the mean and the standard deviation of each company? So what I did is I just kind of gave you some salaries. So if a person makes $30,000 and they work at Company A and they get a $1,000 raise, they're going to make $31,000 next year. If they get a 3% raise, 3% of 30,000 is $900. So next year's salary will be $30,900. Okay? If you move on down the scale, that's kind of what I did. So now I want to think about what happens to the mean and what happens to the standard deviation. Okay? So mean describes the average. Remember, I will add all the numbers up, divide by however many there are, and their average. So basically at Company A, you're adding salaries now that are all $1,000 higher than they were before. Every single person gets $1,000 more than they were before. So at Company A, the mean basically increases $1,000. Okay, it makes sense that the average salary would go up $1,000. At Company B, B describes standard deviation, and standard deviation, remember, is spread. So if you kind of look at the original salaries, the smallest was 30,000, the biggest was 100,000. That's a $70,000 spread. Okay. At Company A, I'm going from 31,000 to 101,000. That's still a $70,000 spread. My numbers are not any more spread out than they were as long as everybody gets a $1,000 raise. And so because my numbers are not any more spread out, my standard deviation actually stays the same. Okay, now let's go to Company B. At Company B, I'm going to add all the numbers in this column right here, and I will add them up and average them to find the mean. Now you're adding and averaging, though, different numbers. Okay, I'm adding 30,900, 41,200. And so what's going to happen is your average is obviously going to be bigger. And just so you know, it will be 3% bigger. Okay, so anytime you're adding a flat dollar amount like I did at Company A, your mean will go up that much and your standard deviation will stay the same as long as you're doing the same thing to every single piece of data point. In this case, I was adding $1,000. That will increase your mean by that much. It will leave your standard deviation or your spread the same. At Company B, we've already talked about their mean. I'm adding 3% to every piece of data, so the mean is going to go up 3%. Now, when we get to standard deviation at Company B, the deal is that 3% of $30,000 is a lot less than 3% of $100,000. If you're making $30,000, you only get a $900 raise. If you're making $100,000, 3% of $100,000 is a $3,000 raise. And so now what's happening is the difference between the lowest paid salary and the highest paid salary becomes bigger because 3% of a bigger number is more. Okay? And so at Company B, the standard deviation is actually also going to increase and go up 3%. So anytime you're raising a flat dollar amount, like in this case $1,000, your mean will go up by that much, your standard deviation will stay the same. If you're multiplying every piece of data by a certain percentage, then your mean and your standard deviation will go up by that percent. All right. If I give you this chart right here and I ask you to describe it with some sort of measure of center, I would like to know which one would be more appropriate. Would the mean and the mean be more appropriate for the measure of center, or would the median be more appropriate for the measure of center? You can see that this piece of data or this chart, this set of data is skewed to the right. Because it's skewed to the right, I would like to use the median. You will use the mean if your data is symmetric. You will use the median if your data is skewed. Then if you would like to describe the distribution, that's how spread out it is. You're going to decide between describing it with the IQR, or the interquartile range, or describing it with a standard deviation. And again, you'll use standard deviation if it is symmetric data. This one is skewed, and so you will be using the IQR would be best to describe that, okay? You'll use the mean and the standard deviation for symmetric data. All right, and that's it.